To analyze this data using SPSS, this is the page it's going to open. There is no way of clearing the data in the memory. You can press OK to perform the analysis. If I want to plot that graph, I would come here to Graphs. You'll be able to perform all your analysis at once. The bad news is that you cannot run Cohen d-test, so you shall run a correlation analysis at bivariate level. So there is a faster way to code your data. I think Stata is much more faster, easier. You can automate. You are welcome to this video. Today we are going to be analyzing the data from the start to the end using SPSS, and this is the data we're going to analyze. So before we go into the analysis, let me provide you with the general overview for that other particular work. Now this work originally was analyzed using Stata. You can see here the Stata commands are available, but for this particular video we will be doing analysis using SPSS. Can we get the same thing if we use Stata? Can we get the same thing using SPSS? The study we are dealing with is a study on the topic comparison of the role of right mindfulness and African wisdom in healing intergenerational trauma. So the study had both the general and then the specific objectives. The general objective was to compare the role of right mindfulness and African wisdom in healing intergenerational trauma. But of course, you have to subdivide these objectives into biteable pieces, because when you're going to do the analysis, you do it bit by bit. So the specific objectives were to evaluate the effect of right mindfulness-based intervention in healing intergenerational trauma. So you have right mindfulness, that is one of the interventions given to the group, and then you have the healing status of the people. So you have to analyze to see what was the effect of that intervention on the healing. The other one was to evaluate the effect of African wisdom-based intervention in healing intergenerational trauma. Again, you have to put that at the back of your mind, then to find out the effect of combination. In case you combine two different interventions, how were people able to heal? How was its performance in that regard? And again, all this I'm trying to show so that once we go into the analysis, you have a clear idea. We shall keep hinting back on this. Why are we doing a given step for the analysis? So this was a completely randomized design. So this was an intervention study. So you have a group T1. Those are the groups that were being given the right mindfulness-based intervention, and the sample size was 33 people. Then we have the T2 people. Those ones were being given the African wisdom-based intervention, and it had the sample size of 33. Then below that, you then have the T3 group. Those are people who are being given both the right mindfulness-based intervention and African wisdom-based intervention. That one also had sample size of 33. Why 33? First of all, you want to have fairly an equal number of participants in all the intervention, so that in case there is an effect in one intervention, it doesn't affect, like it's comparable. It's comparable across all the groups, because somebody may argue out that the difference in sample size could have caused the difference in what we are observing. So you want to make sure that you have equal number or similar number of the participants in all your intervention, so that you are able to compare them well. Of course, these were different cohorts, like different groups of people. So when you were receiving right mindfulness, the participants were those. It was different participants getting the other intervention, also another different one getting the other intervention. So these were different groups of people, but grouped into these three categories. And of course, the fourth category was the control group, which also had 33. Those ones were not being given any intervention at all. They're not given any intervention, because we want to see, okay, if you got the intervention, if you got the treatment, if you got the intervention you are being given, did you heal from the trauma or not? But then if you didn't heal, or if you heal, depending on the status, but are you different from the people who didn't get any treatment? Does the intervention cause some changes to the people who got it? For example, you might have not healed from the intervention, but maybe your condition improved. Let me bring it back to medical. So we are saying, okay, if we are testing these malaria drugs, does this drug work on this patient who has malaria? So we need to also get people who don't have malaria. Or we can get people who have malaria, but we don't give them the medication. So then we say, after 1 week of giving somebody medication, the people who are having malaria and didn't get the medication, let's say they had 100 germs in their blood. They remained with 100 from the start of day 1 up to day 7. They still had the 100 germs in their body because they didn't get any intervention. They didn't get any treatment. But the people who had the disease, but then they got treatment, let's say the germs reduced to like 10. From 100 now it is 10. Okay. So this drug can reduce the germs from 100 to 10. So that is what. So without the control group, it is hard to try to argue out the variation. That's why it was important. Now the calculation of sample size was done via different methods, and both using formulas and then also using the software, the starter software. Now there is a video of some calculating sample size using starter, and so that video already went through how to calculate sample size, this specific sample size using the starter software. So feel free to revisit in case you have forgotten how to calculate that sample size using starter. Inclusion criteria, exclusion, not really important, but these were what was being done to include or exclude you from the study. Measurement of the variables. So we had both the quantitative measurement of the variables using the 5-point Likert scale. So agree, strongly agree, strongly disagree, disagree, neutral. Those are the different points. So the data set we are going to be seeing, you will be able to see those different values in there. So when I open the data set, that's the data set for SPSS. That's what we want to use. The data set is divided into different sections. So here we have the demographic section, the demographic page. So it has only demographic information for the participants. So remember, we have 4 groups: T1, T2, T3, and T4. Each of them had 33. Yes. So 33 times 4 gives around approximately 132. Remember, the first row is taken up by the column title. Then we also have a section that has the right mindfulness intervention. That's the intervention group. So these are the different scores for the people. These are different scores for the participants. And if you can see some values here, they have 1, 2, 3, 1, 2, 3, 1, 2, 3, because the information was collected in a Likert scale format. Now, we will go through what we're observing in here, but what's important is that for a different section, let's say it is right mindfulness as an intervention, they had again different categories: right understanding, right understanding, like the right thoughts, right action. So it had different subsections that are available. But again, under each of those subsections, there were questions being asked. I understand the truth of suffering. I abandon the thought of non-existence, something like that. Like there are so many other subsections under those different questions, and people were supposed to ask in a Likert scale, were supposed to answer in a Likert scale format. Even in a control group for right mindfulness, every intervention had a control group. So the 33 T4, which was a control group, was divided amidst all these other 3 interventions. So right mindfulness got 11 participants for the control. The African wisdom also had 11, and then the combination group also had 11 controls. So those are different controls, how they were subdivided. Now, that is generally how the data is. Now, the data also, I've organized it in some way that because there will be other subsections like calculation of the Cohen D test, which is if you reach the paired t-test analysis to compare the baseline and the end line, because the data, the information was recorded at baseline. What was the people's knowledge at the baseline level? Then what was their knowledge at the end line level? What was the trauma status at baseline level versus the trauma status at end line level? What were the scores? So when you want to see the change between baseline and then the end line, you'd also want to find out the effect size, the effectiveness of that change, what you call the effect size, the Cohen D test, on top of the p-value. Of course, you can use the p-value to try to look at the comparison in the scores, but sometimes p-value may be a little bit misleading because something may not be statistically significant, but you may still find it is offering, it is doing some work. It is doing some work. So going back to the example of the medication I was talking about, you may find the medicine did not clear the germs from 100 to 0. It cleared from 100 to 10. But you can say, okay, 100 to 10, though it didn't clear up to 0, but it can reduce the number of germs in a person's body. Let us recommend still the drug as the first line treatment. In case you don't have many germs in your body, the drug may clear it. So let us recommend for this initial start. But if the condition persists, we can recommend something better. Now, Cohen D test can help you assess that. Does this has an effect size, although it is not statistically significant, but does it have some effect size, and we can go ahead with it. So we have a number of subsections that this dataset has been divided, like to make analysis easier. But all of this dataset was generally a single dataset, but it has been subdivided to make the analysis much easier. So this is a dataset that we will be dealing with. Okay, now there was also the qualitative section for the data which was collected. So participants were asked, they were audio recorded, transcription was done using the Atlas software, and then a PDF document was generated that has the transcript of the participants. But that is not going to be the focus of this analysis, because this is Atlas, it's not SPSS. So we only want to deal with SPSS. So out of what we have all described, this is how it generally looks like. Generally, this is the conceptual framework. So we have the right mindfulness, one of the interventions, and under them we have different elements: right understanding, right thoughts, right action, right speech, right livelihood, right efforts, right mindfulness as another subsection, and then right concentration. Now all these are different elements that the different interventions, elements, teachings, treatments, no matter how you want to refer it to, that were being given to people. All of them combined were forming part of the right mindfulness intervention. So the data will be having information in this area, and also the combined score for all of these that gives us the overall score for the right mindfulness, because you need this overall score to perform some comparison. Under the African wisdom, you had African proverb or wisdom, the African philosophy, the African moral laws, that is the math, the African moral laws, that is speech still. So we had African moral laws, but specifically relying on action. African moral laws relying on speech. African moral laws relying on livelihood. Then also had striving or energy. We had the African proverbs, that is paying close attention to one's experience, then focusing on one's mind. Those are subsection. Again, under African wisdom, all these questions were designed so that it can mirror the questions or the intervention for the right mindfulness. Because again, you want to give an intervention which is similar to the previous one for better comparison. Also now in the combination, people got the combination of the above, they also came up with the intervention that was similar to these other previous one. But of course, the teachings and whatever was being taught inside there had to match what the study was trying to do. The study also collected, remember, the healing from intergenerational trauma. So the healing focused on either physical well-being, emotional or mental well-being, the social well-being, or the spiritual well-being. All combined would give the healing status of somebody. Right, that is it. Now, there are also other controlling variables that were collected, that is things like the age, gender, marital status, religion, etc. Like all these demographics information, these are controlling variables, and we shall see how we are able to analyze this data, or you can analyze this data so that you're able to find out its effects at the end of the day. Because the assumption is that whereas you may want to teach people, give all this intervention for them to heal from that trauma, but some of these factors can again influence their healing. It can influence it. There are so many things that can influence. So it would also be important to look at how the controlling variables are influencing healing, like for these people. So to analyze this data using SPSS, we open our software. So make sure you can just open your software, run as administrator, or if you're a user, run as a user. Now you need to be having the software installed within your computer. SPSS sadly is not a free software, so you need to buy the license. But if you can borrow from a friend or you can get from school, people are always willing to share softwares with a license, and you can always use that accordingly. So when you open SPSS, what I don't like about SPSS is that it's a little bit like slower. It also consumes a very large size of like CPU, like space or power within the computer. Unlike Starter, I always use 95% of my analysis I do conduct them in Starter. It's much faster. You can create this code, this command, you can automate things, but SPSS is very manual. Like it's really manual. If you open your SPSS, this is the page it's going to open. Like this is going to be a page that's going to open. So you'll find that there are three windows. There is the window which is for data. This behind it looks like an Excel worksheet. Then there is this other window which gives the option to run, upload data, open another type of data, something like that, which has so many other options, type of data, run an existing query. There are so many other things that you can do from around here. There are so many options. It just makes it easier for you to like begin this workspace with some form of data. Then the other window is this right hand side one, which is what you call the output window. So in case you perform your analysis, you'll be seeing the output from here. So it has all these multiple things. Again, if this one, if you're doing something in Starter, for example, if you have the Starter software and then you open it, Starter has most of its thing here. Like it only shows you a one section, like the first time you open. So it doesn't bring all those other multiple sections. It's only when you begin browsing to look for where data is, that's when it brings another page. That looks like Excel. It comes in here. If you want to import data, you'll find where to import here. Then it brings in that other part, which is looking like an SPSS. So, but in SPSS, it's sort of open for you all this menu at the initial start. Of course, you don't necessarily have to use it in the first point. You can always click on cancel, then it removes that other section, then you remain with an open page. So on SPSS, you have the data view section. That is this view we are looking at. It is more like an Excel kind of view. You also have the variable window section. So you have those sections. So when we import our data, we shall be seeing variables in here, the list of variables we have, the data types and everything, it will appear there. So the variable window, you have the name of the variable, the type of the data, the width, the decimals, the labels, values. It has all this other information that we shall be seeing about our variables. So those are the two different sections we have. Now, let us import our data. To import data, into SPSS. Remember, we're going to analyze, and the first thing for every analysis is to perform the background characteristics, the descriptive statistics for the profile. You need to give us what were the characteristics of your participants. That is in case you recruited people. If your analysis is maybe experimental in a lab work, you may not really need to do this, but still you may say, I had this number of samples, they were of this sample type. Still, you have to do some descriptive stat, I think, in my opinion. So in this case for us, we are going to do the descriptive statistics for the demographic information about our participants. So come here under File if you want to import. To import on SPSS, come to File, come to Open, click on Data, right? Click on Data. Make sure we have changed our data here. Remember, our data is Excel format. It's an Excel worksheet, so change it into Excel. So this is where you change your data type, Excel. If you don't change, when you go to your location, you will not be able to find that data. It will not be there if it is an Excel format. If it's in any other format, choose that other format accordingly. See, there is also starter, the .dta. These are starter files. In case you have data from starter, it will be a .dta starter. So there are other file formats you can always import. After that, so I'm calling it importing. I'm used to the word importing because under starter, if you're using starter for data analysis, it is always import. Then you go to Excel. But under SPSS is not like import as per se, it is more like open. So open. So, but I'm used to the word import because it makes it like you can easily understand that you want to bring data from wherever it is you want to bring it this other side. All right, so let me look for where the data is. That is located under local disk F. Where is YouTube? Here. The data is located under static gene. That is the static gene folder, which is this one. It's located under project. It's located under mindfulness study. The data sets SPSS. So navigate to where your data is, wherever the data set you have, and then you click on open. So when you click on open, it is going to load. The first default, it will be like read variable names from the first row of the data. This is what it means. If you come to your Excel worksheet, you see like there is this first row that has like sort of like the column title. Starter all in general, it expects that most of the data will always have like a column title, and if it is an Excel worksheet, that column title is going to be on the first row here. So you need to import this first row as the variable name, because if you don't report that as a variable name, it's going to import ABCD, this upper one. It will take this ABCD as a variable name. So let me show you an example. So if I click this off, remember, these are the different worksheets you have within the Excel. As I showed you earlier, this Excel has multiple worksheets. So I need this first one for demographics. So if you don't choose this first one as read variable names from the first row of the data, if you don't choose that and you press OK, what it's going to do is that after importing the data, this is going to be the variable name, V1, V2, V3, V4, V5. It has taken that as a variable name. When I go to the variable viewer, I can see that the name is V1, V2, V3, V4. Yet, in the actual sense, we want it to be districts of residence, female, male, gender, age category. That is what we want it to be. Okay, so we have to change that. We cannot. So yeah, this one means that we have imported it badly. So we have to remove that data. We need to bring a new data set. Now with the SPSS, there is no way of clearing the data in the memory. You can either close or you import another data on top of this, but then you'll have multiple worksheets. Again, if that was starter, you'd just do clear. Let's say you had imported this data. So we have imported it using starter, and if I browse BR, you can see the data is in here. This is starter. Look at the appearance of the data. It's the same way that it is appearing under SPSS, because again I didn't import the first row as the variable name. I didn't read that first row, so it is recording it like that. So, but if I wanted to remove this data away from starter, I would just do command clear. Command clear would remove that data set from memory. Then I would go and begin importing another data afresh. That is not the case with the SPSS. With the SPSS, if you have data in the memory already, either open a new data, something like this, open new data, or you can just strictly just go and override by just saying data, and then again you open afresh. So when you click that, change this to Excel, this is where my data is located, SPSS. I click on open. I want this demographics, okay? Then I press OK. It will now load the new data, but the previous one is also located. So I can now close off this previous one. Do you want to save changes? No. So you can now close the previous one so that you remain with the new data in here. The question is, what do we really want to do with this particular data set here? Does it require cleaning? Does it? Yeah. You should do some cleaning. All right. So you do some cleaning, ensure that is the data okay? Are there missing values? If not, what is it? You can do those few cleanings here and there if you want to really do that. Something to note is that not every data should be analyzed using the SPSS thing. There's some other responses that may be multiple, like they may be very, very many. The question can be like, what is your relationship with that person? Father, mother, employee, nephew, sister. You can have multiple responses. Wife, husband. It may be really multiple. And like if you try to do frequencies and percentages, then it may not come out well. So to perform the analysis, you want to perform the descriptive analysis, what you will do, come to Analyze, come to Descriptive Statistics, and then you choose frequencies. That is in case you want to report in terms of frequencies and percentages, for like how this table is. So districts of residence, you have where the people are from, then frequencies, and then percentages. Now, some other analysis do require you to add in the confidence interval. So you can always have another section showing the confidence interval for these different percentages. So to get these statistics, so you'd come, as I said, come to Analyze, come to Descriptive, choose frequencies. Then choose the variables you want to analyze. You can, of course, choose one variable per time. So click on that variable and then press this this arrow going towards the side. Then you click there, it will take it there. Or when you click on the variable, you can double click twice. 1, 2, like twice, faster. It will also automatically transfer that given variable to the right hand side. If you want to bring them back this side, click on what you want to take back, press this arrow. Automatically, when you click on something on the right hand side, the arrow will turn back to the left, thinking you want to take it back. Then you can always click there to take it back. Click there, or you double click, it will take it back. All right. Now, if I do districts of residence, then I take it this side. You could press OK to display frequency tables. Make sure this one is ticked. But you can check some few statistics. When you click on statistics, do you want to add the quartiles, cutoff, percentiles, mean, median, mode, sum? Depending if you want to report some other additional information, you can always request accordingly in here. Standard deviation, if you want, you can report that. Variance, skewness, etc. Of course, you need to be having some theory behind. You know that if I want to report frequencies and percentages, you can report standard deviation because the data in this case is discrete. Districts, where somebody is coming from, those are discrete values. They are non-continuous values. Okay? They are categorical in nature. So you cannot report standard deviation. Standard deviation would be okay if you're dealing with the numerical data and you want to calculate like mean. Okay? So there are some other few statistics that you have to just think whether do you want it or not. Under charts here, you can choose whether on top of them presenting for you the values, do you want it to plot some charts for you? You can click in advanced, then charts will also be plotted at the same time. If I do not want, I want none. I do not want any charts. Under format, you can choose. Do you want to display in ascending values, descending, ascending counts, descending, depending on how you want the output to be displayed, but it doesn't matter. Bootstrap, do you want it to perform some other extended or extensive analysis for you? Do you want other more like output to be given for you? And again, this is also where you have the confidence intervals for the percentages. Now that you need to turn it on if you want to display the confidence interval for your different percentages, the percentiles that are going to be displayed. So make that on, leave these values as default, make sure the confidence interval percentile is ticked, and let it just be a simple sampling, nothing much important, because that it will display for you the confidence interval. So when that is done and you have chosen your variable, you can press OK. It will perform the analysis and then it displays for you some analysis in here. Now what is most important is that in this beginning phase, there's nothing really important in here, just the bootstrap value, which is not really important. Then we have here the frequency, showing you the variable name, how many valid numbers are there, biased. Then the confidence interval is here. That is for the frequency in here, then the counts. When you come down here, it will now display for you another extended version of the table. It has the frequencies, it has the percentages in one decimal place. Then on the right hand side, you have the confidence interval for where you different percentages lie. Like this is 95.5, so this is the confidence interval. So you can now report also that on top of it. So it depends. If they all want you to report the variable, the frequencies, the percentages, and the confidence interval, that is the easiest way you would be able to get the confidence interval from that given data. So for our descriptive stat, demographic characteristics, you do the same. When you go back again to analyze descriptive statistics, frequencies, you can see that the previous variable is inside there. Now, if you don't want it to appear again, you have to take it back, then choose the next variable, gender. Also, the settings in here, it has been captured already. Whatever you set initially, it remains captured in there. It doesn't change. Under Bootstrap, you see, the confidence interval is still pre-ticked. So for this given session of starter, it masters whatever settings you have done, so you don't have to repeat it every time. That is for the females, the gender. It will perform the analysis. Then down here, it will display female, male. There was 76 female, 56 male. Then these are the percentages here. Then this is the confidence interval. This other middle one is not always unimportant statistics to really report. So I don't always bother reporting that one. Only report this end and the other end. Now, something you have to note is that there is this thing called coding, 1, 2, 1, 2. I always don't like coding data. You know where they always say 1 means male, 2 means female, 1 means male, 2 means female. I've always not loved coding because it makes interpretation very complicated. But we are going to see in the analysis in front where coding will be important once we come into logistic regression analysis. And I'll show you the easiest way to do coding that you don't have to do 1, 2, 1, 2. It will be a very fast way for you to do coding, and then you will still be able to read these values as the way they are appearing. Because if you do coding, now this would be 2 for female, 1 for male. So you have to keep on remembering in your head what is 2, what is 1, what is. So I always don't prefer coding. I always prefer to work out the names as they're appearing in the original data set, so that it makes it easier and faster for you to interpret. But you can also do this demographic characteristics analysis in a single analysis. Just come to Analyze, Descriptive Statistics, Frequencies. Let's say this is empty. So you can actually be able to choose every variable in here. So you can click on one, hold the Control button, and then choose the rest. Okay, choose the rest. All the variables you want to analyze, choose it, that, and then you use this arrow, take it that side. The other option is you can choose one, hold the Shift button, use the down key. While holding the Shift button, use the down key to be selecting what you want, and then you take it the other side. The other option is You can do Control A to choose everything. If you're sure that all the variables you want is everything there, do Control A, and then you can push it the other side. The other option is to do one by one. Choose districts, take it this other side. Gender, take it. Age category, take. Religion, take. Marital status, take. Are you living with somebody? Take. Depending on the variables you want to analyze, push it the other side, then you can press OK. It will perform that analysis for all the variables, but it will display for you. If you look at here, this sort of like the command, frequency variables, then it has listed all the other variables you want to analyze. Then it will display for you some few statistics for that. But the most important thing is the frequency table. This weeks of resident, it displays for you. Gender, it displays for you. Age category, it displays for you. All the statistics you want. Then you can come back into your write-up, then you perform the write-up. So you put it in a tabular format, like how this is put. Then you perform the write-up, you interpret it as normally. Most respondents were from Kampala, blah, 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 blah. Most 57.58% of them were females. So when I take this on the right-hand side, I can see that if I want to compare whether these statistics are correct or not. Okay, let's choose like this is religion in here. So here religion says from the write-up, regional write-up using starter, it says that okay, where is it? Participants' religious affiliations were diverse, with the Islam and Anglicans each representing 30.30 and 29. So Islams were 30.30%, Islam 30.3. So that is the percentage in there. Okay, Catholics and born-agains were 22.2 and 17.43 respectively. So Catholics were 22.73, this is 22.7. When you run it off the one decimal place, this is what SPSS is bringing. Let me choose another random variable again. So let's go back to, let us choose marital status in here. Marital status here. So here, marital status, where are we? So majority of the participants, that is 50.00, were single. So we can see single people here were 50.0. All right. Next, the married people were 37.12%. Married is here 37.1 when you round it off to one decimal place. So we are so far okay. SPSS is agreeing with this data which was analyzed using starter. Now what you need to note is that there was these other graphs which were plotted. As I said earlier, sometimes some data may have so many categories that if you put it in a table, it will be so long and it doesn't make much sense. So some variables you can always choose to present them in a graphical format. So this graph was plotted using Excel. I plotted using Excel. But you could attempt to plot this using SPSS. But if I want to plot that graph, I would come here to Graphs, choose a graph builder, then OK. Choose the variable you want to plot, that is question 2.8. Let me choose the type I want. I want this type of graph, so that is it. So I choose this. I want this to be on the x-axis. See, so it has plotted for us, and in this case, it has plotted counts. I can change that to percentage. Apply. All right, so it has changed this to percentage, and it has plotted for us that particular graph. I can press OK, and then it will build the graph, and now the graph is here. It has been plotted. Of course, it has arranged it from the lowest to the highest. Try also plotting for these, what is the relationship with the person that has ever experienced intergenerational trauma. So when you want to plot this graph, this one again we plotted it using Excel. If I want to plot that graph, I come here to Graph, come to Chart Builder, choose here OK. Originally, we had some graphs already plotted in here, so I do not want that. So I can drag it backward, like take it back to the variable. Choose the variable that I want. Question 2.11. What is your relationship with somebody with the intergenerational trauma? So that is question 2.11. Question 2.11 is here. So I drag that, put in the x-axis, and then it will plot for me that particular graph. When I press OK, it will generate for me that graph there for me. So we are basically done with that first section for the analysis. The other section for the analysis, we are going to analyze to see, does the first intervention, objective 1, does right mindfulness have an effect on healing intergenerational trauma. Again, we should remember that this data was collected Likert scale of 1 up to 5, and that Likert scale tend to have a meaning now. So once we're doing our analysis, we will be able to get the mean score for a given participant and overall mean score. So if the mean falls within any of these values, this will be the interpretation. The standard deviation also, because this is numerical data now, you have to report standard deviation. If the standard deviation falls within any of these categories, we will report it as small effect, high reliability in case standard deviation is 0.00 to 0.49. If the standard deviation is high, from 0.5 and above to 0.99, we shall say that it has large effect and low reliability. As I said earlier on, this data, each variable, like this intervention is right understanding, but under right understanding, there were again subcategories. Right understanding, we had the right thoughts, we had right speech, there are so many other subcategories in between them. What we are aiming to do is that, remember, we have both the intervention group and the control group. Now, under a section, right understanding has a subsection under the whole intervention of right understanding based intervention. This is the overall intervention name. Now, under that section, the first data was for right understanding also. So that subsection had a similar name to the overall intervention name, so don't get confused. So we have right understanding in here. Now these are the sub questions, the different questions which were being asked for that. So we want to analyze and see in the intervention group what was the performance end-line versus baseline, end-line versus baseline, end-line versus baseline. What were the different performance for the people? That's what we want to analyze. Then it gets the standard deviation and then the main difference. So for us to compare this baseline and end-line, the simplest thing to do is to do a paired t-test. Remember, these were same participants, same people. You ask them at baseline, then again you ask them at end-line. Now that is a paired t-test analysis. If you want to compare the mean score, the mean value, comparing means of the people that were in the same group, we always use a paired t-test. So we are going to do the right understanding. Now, let's import that this data was on the demographics. Now we don't want that. Now we have to bring new data. So I go to File, go to New, click on Data, change this to Excel, choose Data, which is data sets for SPSS, press Open, come here. Here is it. Right M. This RM stands for the right mindfulness of the intervention group. Right mindfulness intervention group. That's the data I want first of all. Say read variable name from the first row of the data. Yes, okay, because you want that variable to have a name. Because when you come back to Excel, the RM int, right mindfulness intervention, row 1 was the column name, the variable name. So we want to report that as our variable name. So we have imported our data. This is what we have. So we want to start with the right understanding. And there were 4 subsections. That's what we want to start with in the intervention group. So this is the part we want to analyze first. So when you go back to our data, let me close this demographics data. I don't want to save, no. I only want to remain with the data for the right mindfulness. This is what we have. Now this data set has been arranged in that. Remember we said we have the right understanding. There are 4 questions asked. I understand truth of suffering, abandon, existence, I develop. Those are the 4. These 4. The RU1, RU2, RU3, RU4. When you come here, here's that understand suffering, abandon, the end of suffering, I develop. These are the 4 questions asked. All of them are under right understanding. So we're using the abbreviation RU for right understanding, question 1. Right understanding, question 2. Right understanding, question 3. That's why you have RU1, RU2, RU3, RU4. But also something to note is that on top of that, the data was also collected both endline and baseline. So we have both the baseline and the endline. So to differentiate that, we have added B. If there is B, that stands for baseline, baseline. If there is E, that stands for endline. So in this particular case, this is RU question 1 baseline, then this is RU question 1 endline. This is RU question 2 baseline, this is RU question 2 endline. So we made sure that this data is within, like nearer to each other. So when you want to compare question 1 baseline versus question 1 endline, you just do this versus that. Question 2 endline baseline versus question 2 endline, you just do this versus that, this versus that, this versus that for that particular case. Then we have the overall for that section here. This one in bold, right understanding in general. The overall mean for these scores. So this is it. So that one is also here. So it's this column. So this is right understanding baseline in general. This is right understanding endline in general. So those are the 5 items we want to analyze. So to do that, I go to Analyze, go to Compare Means, go to Paired Sample T-Tests, then it opens for you these pairs. This is very, very easy and straightforward. Stick with me here. So based on how our data is appearing, let's begin with the overall. So I want endline, baseline. So preferably you are supposed to choose endline first. So I want let me take this back first. Let us begin with over. The overall is this RUE, RUB. So I choose the endline for the overall right understanding endline. It will appear as the variable 1. I'm going to compare it with variable 2, which is the right understanding baseline. Take it aside. Then I come to question 1. Question 1, as per how it's appearing here, this is question 1, question 2, question 3, question 4. I keep on comparing. So question 1 endline versus question 1 baseline. Question 2 endline versus question 2 baseline. Question 3 endline versus question 3 baseline. Question 4 endline versus question 4 baseline. Those are all the pairs I have for that section. And the options in here, yes, I want confidence interval, exclude cases, analysis by analysis. It's not important, leave it default. And the bootstrap, is there anything you need from here? Nothing much that you can, or don't bother putting anything here, just let it remain as default. Then you press OK. It will perform for you the analysis very well. The first part, it shows you the different mean. The overall mean for the endline, baseline. Question 1 endline, question 1 baseline. It performs for you that reports the mean, standard deviation for that mean, then the standard error and the number of observations. Again, we keep on going down. Then it reports for you the paired samples correlation. This is like a correlation analysis. So these are the correlation values, and then it's p-value. We don't really need correlation value at this point, but still it does for you that analysis. This is what we want, the sample t-test. So if we compare the score, now you see now the pair in here is right understanding endline minus right understanding baseline. This is the mean difference. This is the standard deviation. Then this is the confidence interval. We don't need the standard confidence interval. This is the t-value in case we wanted to report the t-value, because we have performed a paired sample t-test. This will be a t-value, degree of freedom, and then the significance. Also for these. So what you need to note is what equation are they doing? This is endline minus baseline, endline minus baseline, endline minus baseline. So how we were putting pairs the other side, the first pair you put at first. If I go back to Analyze, compare mean, pair t-test. These pairs we have been putting in here. What we have put as variable 1, it will be taken as the first variable minus the second variable. It's like variable 1 minus variable 2. Variable 1 minus variable 2. So when you interchange, the calculation is going to be reversed. And then the value, if the values were supposed to be positive, it will be negative. If it was supposed to be negative, it will be positive. But of course, it will have still made that subtraction for you. So if we compare our output with what we have in our write-up, so we can see that for the overall score here, the baseline, we have the baseline value in here. So let us go up first. So the baseline mean for the right understanding is 1.818. The right understanding baseline B, 1.818. So we have that. Standard deviation is 0.516, 0.516, that is here. That's what we have. So in this first 3 section, it's what is reported in here. We have the baseline score and also the endline score, which is the right understanding endline. The mean is 1.603, 1.603. Standard deviation is 0.489, something like that. That is it. Next, we want to report the mean difference in between there. That's when we come down here, then find the mean difference, minus 0.215. Minus 0.215. That is what we have it reported. So that's the same thing with each and everybody here. If you go to question 4, for example, if you randomly go to question number 4, the RU for the pair, that's the fourth pair, the RU4 is in here. We can see that the difference in the mean is negative 0.152. Negative 0.152 is what we have. If you randomly choose, let's say, the mean of question 2 end line of the intervention, question 2, RU2 end line is here, the mean is 1.64. You can see that the end line is 1.64. So that is how you report that. So you can perform that same analysis even when you come under the right thoughts. You just exactly perform that same analysis. You have the overall score and then you have all these other individual scores. You perform that same analysis. Right speech, it's the same thing. So under SPSS in here, literally, we could go back to Analyse, then we come to compare means, paired sample t-test. Let's say I remove back all these pairs. Just click anywhere, do Control A, take it back. Alright, so we have taken them back. You could literally do everything. For example, I said my first pair is going to be right understanding end line, right understanding baseline, first pair. Now, right understanding end line, right understanding question 1 end line versus right understanding question 1 baseline. Right understanding question 2 end line versus right understanding question 2 baseline. Ensure that the pairs are matching. Keep on going. Question 3 end line, question 3 baseline. Question 4 end line, question 4 baseline. That one we are done for the right understanding as a subsection. So we go then to the next variable. From this RTB, RTE. So these are the values we want from here up to this section. Endline RTE, that's RT endline, RT baseline. RT question 1 endline, RT question 1 baseline. RT question 2 endline, RT question 2 baseline. RT question 3 endline versus RT question 3 baseline. RT question 4 endline versus RT question 4 baseline. Now we are done with the data section. Now we go to the next. This is RA, right action, right action. So RA, right action baseline, RA, right action endline. But under right action baseline, again, there are sub questions. So we want to compare the baseline versus the endline. So you'd again do the same thing. RA endline in general versus RA endline baseline. Then we go to the question. So we have RA endline question 1, RA baseline question 1, RA question 2 endline versus RA question 2 baseline, RA question 3 endline versus RA question 3 endline, RA question 4 endline versus RA question 4 baseline. Again, we are done with that group. So you can keep on adding as more as possible, and then you just press OK. It will execute for you all that analysis at once, and now you will just be able now to begin comparing all the different pairs you have. Begin comparing all the different pairs you have. You'll be able to have all your mean difference in here. This is under the paired sample t-test. This mean you're seeing here is the mean difference. That's why we have the equations in here. So you'll be able to perform all your analysis at once. So when you come here and this write speech, you can just upload all this at once. Write action, upload all the data at once. Write livelihood, do it at once. Write efforts, do it at once. Remember, that is the intervention group. Now there is also the control data. If you remember, if you come here under control, again, the control also is also aligned the same way. The control, write mindfulness-based intervention, then it keeps on going. So you just repeat that same thing, both in the intervention group and then in the control group for the right mindfulness. Now, once you go under African wisdom, it's still the same arrangement. The layout is the same. Everything is literally the same. So this is, let's say, this is the African Proverbs baseline. This is it. Then this is African Proverbs endline. This is it. But there are questions 1, 2, 3, 4, 5 that was asked to come up with this baseline. Then again, these were the questions that were asked to come up with this endline. So you do the same comparison. You would again compare, okay, African Proverb endline versus African Proverb baseline. African Proverb question 1 endline versus African Proverb question 1 baseline. You keep on doing the 2 pairs, keep on doing the 2 pairs, keep on doing the 2 pairs across all the different data sets which is available. Then the reporting will still be the same in this table. Now, remember when you're doing now the reporting thing, the mean diff, you report the mean difference, you report report the mean. In this case, when you want to report the mean difference and then the standard deviation. And we have already also said that the standard deviation is that if we have something which is less than 0.5, that is going to be where the interpretation, standard deviation, less than 0.5, small effect, high reliability. More than 0.5, large effect, low reliability. That is how you would report, that's the criteria you would use for reporting these values here. That is how the whole of this section would be analyzed. You could literally do only 3. You import data for right mindfulness intervention, do the all of those pairs at once. Clear that. Report the right mindfulness control, do the same pairs all at once. Clear that. Report data for African wisdom intervention, do it. Report the data for African wisdom control group, do the same pairs. Report the data for the combination intervention, do the pairs, report. So that's the same way the whole of this section for the data was analyzed. Let us go to the next section then. There is a small subsection within the analysis which we wanted, because what we are trying to compare is like what were the scores for the people against all the elements of the intervention. It was not really it was not really about did this person heal, did he not heal? Of course, the theory is that if you have improvements in your right understanding, you have improvements in your African wisdom, we expect that you also improve in your trauma score. Yeah, reason being because all these interventions were aimed towards managing trauma. So that is what the whole aim was. But also we thought of what if we can do a separate analysis for the different score. So we call that the Cohen analysis. So we compare the healing before and after, then you get the p-value, and then you get the Cohen d value to look at the effect size. And so it is still similar to what we have done, but now in this case we want to add an extra statistics in it. Now there is bad news and both good news for Cohen d test. In SPSS, the bad news is that you cannot run Cohen d test if you have an older version of SPSS. You need version 27 or higher to be able to run Cohen D test. The older versions before these, you cannot run the Cohen D test. So the good news is, if you want to run Cohen D test via SPSS, make sure you upgrade your SPSS software to account for to be 27 version 27 or higher. And if you happen to update your software, once you come to the paired t-test, in the options for paired t-test, there will be an option of performing the Cohen d-test, and your output will look something like this. So your output will look something like the Cohen d-test, and then you have the standardizer value, then the point estimate, then the confidence interval. The point estimate will be your Cohen d value. So that is it. So we cannot run. Currently, I'm using version 24. So version 24 doesn't have Cohen d test, so we cannot perform the Cohen d test that we're supposed to do. But literally, after you doing this, is how you'd report. So we are going to get the healing status, that is at the end of the protocol, and then the healing status, that is the before. So you have the end and then the before. You get the standard deviation, because you do it when you're doing the paired t-test still, but it is an additional option. So that would come as an additional option. So it means that you'd still report the t-value because you're doing the paired t-test, the p-value from the t-test, and then you'd be able to have that additional statistics for the Cohen d value. And the interpretation for the Cohen d value, you can check that out, what each of them means, but which one is large effect size, small effect size. But this is small effect size, 0.007. That is a very small effect size. Now we are literally done with that section for the analysis. So the other part for the analysis, after you doing all those analyses, is we have the diagnostic or the correlation analysis. So in this data, we will also do the diagnostic correlation analysis. We shall run a correlation analysis at bivariate level for presenting, to present our data of choice. So we're going to run correlation for the right mindfulness. The thing we want to do here is that, is there a correlation between right mindfulness score at baseline versus the healing status at baseline versus the right mindfulness at endline versus the healing status at endline? Like, we just do different possible pairs, and then we see whether is it a strong correlation, weak correlation, is it statistically significant or not. So from the output here, what we have in here is if there is 1, that is a perfect correlation. So in this case, 1, like from our variable, this is our variables, 1, 2, 3, 4. Also the same as here, 1, 2, 3, 4. So here we could have also put right mindfulness baseline up here, right mindfulness baseline, something like this. But because of space, we just thought, okay, let's just abbreviate. Where you said right mindfulness baseline, it will be 1. So up here, where you see 1, 1, those are right mindfulness baseline. So it's the same thing. If you see 2 up here, so that is the healing, the healing from intergenerational trauma baseline, something like that. So when you run a correlation between right mindfulness baseline score versus the baseline score, automatically you get 1 because it will be a perfect score. But if it is healing from the trauma versus number 1, which is right mindfulness baseline, this is the correlation value, the correlation coefficient. And if it has asterisk, it means that the correlation is significant at 0.01 level of significance. So that is it. So instead of adding p-value, p is equal to this, you can literally just put the correlation coefficient value, and then you can add the asterisk to mean that it was significant, or if it doesn't have that asterisk, it means that it was not significant at your level of significance. Yeah, like it was not significant at either 0.05 level of significance or 0.01 level of significance, depending on the analysis you want to analyze. Yeah. So we are going to try to replicate this. So we did the correlation for right mindfulness. We also did the one for African wisdom, and then we performed the one for the right mindfulness and afternoon wisdom. That is the combination. Of course, remember we still have the intervention groups and then the control groups for each of those interventions. So let us begin by right mindfulness intervention group. So to perform correlation within the right mindfulness intervention group, so what I'm going to do, go and try to import your data, open Excel, dataset for SPSS. The data I want to import is the hypothesis data. Then you say read variable names from the first row of the data. Okay, that's the data we want to use. Remove the previous data that you have been using. We don't need that now. All I need is this new data. In this new data, it has different scores, the different things I need. The most important thing is that it is divided. Up here you have right mindfulness. Up there, right mindfulness, both in the control and then the intervention group. It goes up to here. Next, AW African wisdom starts from this 16. African wisdom goes up to there. Next is the combination of right mindfulness, African wisdom. So this one is the combination. People who are receiving both, like all those other different treatments. So that is what we have. So that is all. So when I want to perform the first section, I just consider between these between number 1 up to number 15. That range, that is where I will be able to have the right mindfulness based comparison. So to conduct that analysis after importing now, you know what do we want to compare here? We want to compare the right mindfulness score at baseline versus the healing state at baseline, the right mindfulness at endline, the healing at endline, but for the right mindfulness based intervention group. So what we're going to do is that if I come to analyze, wherever you are, whether you're at the output section or you are within the data section, which is the data view, this is how the data is looking like. So I come here to analyze, I come to correlate. Okay, I choose the bivariate correlation. Then I take the variables I want to correlate all the other side. I have to take it the other side. So this is the right mindfulness based intervention, the baseline score. I want that. This is the right mindfulness intervention DV. That's the healing status at baseline. I want that. Next, this is the right mindfulness control baseline. That's the right mindfulness score for the control group baseline. So let's first leave the control group. Let's only deal with the intervention group first of all. Let's leave the control group. So next, so I want the end line for this. So this is right mindfulness based intervention end line. Then the right mindfulness based intervention DV, the healing status at end line. Those are the first of all the 4 I want. Those are the first 4 we can see here. Intervention group. So those are the first 4 we need. So those are the 4 we need. And the options here, do I need to report mean and standard deviation? Is it really important? We can really confirm that. Do we need? We don't need. We only need the correlation coefficient and then the p-value. So we don't really need that. So you don't take that. Just leave it. You want Pearson? Yes. You want a Pearson correlation? I want that. Two-tail test. Do you want to flag significant correlation? Yes, I want it to flag. All these asterisk we are seeing here in the analysis, we want it to appear. So if that is done, I press OK, then it will perform for me the analysis. That's what I have. So when you compare with what we have in the table, here I was running the analysis for the intervention group. So here I have right mindfulness baseline. Here is right mindfulness baseline. That is okay. Next, I have the healing status, the DV baseline. Also here I have the DV baseline. That's this is it. This is the right mindfulness end line, right mindfulness based intervention end line. This is it. Then lastly, the DV, the healing of the intergenerational trauma end line. That is the DV end line. It is here. So we just compare the values in here. So I can see that if I run 1 versus 1, I get a perfect score of 1. That is a right mindfulness based intervention baseline versus baseline, that is 1. Next, but if it is the healing baseline versus the number one here, which is the mindfulness baseline, I get this correlation coefficient. So this is DV healing is here versus right mindfulness based intervention baseline, which is this. So the correlation coefficient value is 0.727, which is that. And you can see that it has added asterisks there. And it's saying that that 2 asterisk is, it means that correlation is significant at 0.01 level. It is there. And also it adds the p-value. The p-value is p is equal to 0.000. And then the number of pairs it compared were 33 different pairs. The 33 combinations, the pairs. That is what it compared. So that is that value in there. Okay. So whatever possibility you choose, it will always land. Okay, it will always land there. Now remember, when you're reading these, just consider when you divide this into the middle, see it is a perfect, the upper one on the right hand side here is more like the mirror of this previous one. So sometimes we don't bother listing the values in here, because you see here, this is the same as this one. This cell is the same as this cell. This corner is the same as this corner. This corner is the same as this is the same as this, then this is. So sometimes we don't bother. That's why in the table here, when you report, we only report the downer section. We don't bother reporting this other upper section because it is the mirror of these other values in here. So you can see that what we got in Stata is perfect with what we are finding when we have used the SPSS. Now, on the right hand side is the control group. How about when you also want to perform the correlation, but for the control group for that intervention? So again, come back to Analyze, come to Correlate, choose Bivariate. Now I want to take back all these other values I had in here. This time around I want the control group. So you have the right mindfulness control group baseline. I need that. Here you have the right mindfulness DV, the healing status, in the control group baseline. I want that. So I want their endline scores. Then I look for right mindfulness based intervention endline in the control. Yes, I need that. Next is right mindfulness healing in the endline. Yes, I need that. And that is it. Then I can press OK and it will perform that analysis. When you compare with the group here, the control group, I can see that 0.084 is there, 0.214 is there, 0.508, 0.559 is there. So everything is the same. So what we are reporting is the correlation coefficient value, and then we add asterisk to show that it was significant or not. You can of course maybe add the p-value, but then the table becomes very, very crowded. So that same analysis was also done for African wisdom following the same format, and also the combination following the same format. Let's do the combination. So using that same data set still, if I go to Analyze, I go to Correlate, I go to Bivariate. Let me take back what I have here. So the combination should be somewhere down the combination group. All right, so here, okay. So from this V to 9 downwards combination. So I need this. I need right mindfulness and African wisdom based intervention baseline. I need that. Then I need the DV, the dependent variable, the healing status baseline. I need that. Now, if you check the next, this next one has the word CON, meaning that is the control group. That is the control group. So we cannot add that. So that we shall consider it for the next analysis. So I need the intervention group. So here we have the end line. So here I come for right mindfulness and African wisdom inline intervention group INT. So I take that. Then I need right mindfulness, African wisdom, DV inline. I need that. Those are the 4. I run the analysis. So sometimes the data may have so many other columns, but all you have to focus on is what do I want to run? What do I want to analyze? So here you can see that our values are also matching perfectly. 0.690, 0.690 with the 2 asterisk, meaning it was significant because we can see the p-value here is less than 0.05, also less than 0.01 if we are considering 95% confidence interval. So all these values are a perfect mirror of what we have in this analysis. Again, meaning the starter analysis, which was originally done, is agreeing with what SPSS is giving us. You can also do the same for control group. It will still be the same follow-up, same follow-up, same follow-up. So that is basically how you do a correlation analysis using SPSS. Let's look at a sample result in here. So here we are saying that results from the table above shows that the combination of right mindfulness and African wisdom, okay, that is the overall intervention for that group. When you compare it with the healing status, they had a high positive correlation at the baseline. Look at this. This is baseline African wisdom, healing status. This is also baseline, the healing status. Now, when you compare the baseline trauma status, healing status, and also the baseline African wisdom and right mindfulness combination. So this is supposed to be the combination. Okay. So when you compare that combination there, so it means that still there was a bit strong correlation in between them, and it was significant. So it was really closely significant. So generally meaning somebody's African right mindfulness and African wisdom score is associated with somebody's trauma status at baseline. Even when you compare to end line here, end line, this is the end line. African wisdom end line is number 3 versus the healing status end line number 4. So 3 versus 4, which is this. Now this was also a strong correlation, and it was statistically significant. So meaning the combination was working. Okay, the higher the score for the right mindfulness and African wisdom score, the better your healing status. So it was really working. That is how conclusion could be drawn from that. So the results also revealed that the correlation of the combination of right mindfulness and African wisdom at end line was also very high, that association, and it was positive, and it was highly significant, with the p-value being less than 0.05, or you can say less than 0.01 if you're dealing with a 99% confidence interval. So that part is done. That is how you perform the correlation analysis. Now, the next part we are going to go through is how to do we had some bit of a paired sample t-test, and what we are trying to compare is what we have tried to hint already. You tried just to compare the score, the right mindfulness score baseline versus end line using the paired t-test, and then you report complex interval and then standard deviation and all that, and then also you compare for African wisdom, and then you also compare for the right mindfulness, the combination. So which is more like just do the paired t-test for the overall score for all those analyses. So let's do paired sample t-test and we'll see how it goes. So the next part of the analysis, which is the paired sample t-test, all we want to do is that we want to compare the healing statuses of the people who got right mindfulness, then also the people who got African wisdom, and then the people who got the combination. And all we can see is that we just compare the baseline score versus the end score of the dependent variable for all the different interventions. So we're going to do both for the intervention group and then the control group. Then we go to the African wisdom, also you do the same, intervention group and then the control group. So to begin with the right mindfulness intervention group, if I go and then import the data for the paired t-test, the data for the paired t-test is here, Excel, open. So it is here, the paired t-test, I choose that. Make sure this one is ticked, read variable names from the first row of the data, okay. So I've imported the data, this is what I have. So in the data, this is right mindfulness DV, so there's a healing status for the people who took right mindfulness intervention baseline. Right mindfulness healing status baseline, but for the control group. Right mindfulness healing status end line intervention group. Right mindfulness healing status end line control group. African wisdom healing status baseline intervention group. African wisdom healing status baseline control group. African wisdom healing status end line intervention group. African wisdom healing status end line in the control group. Then the combination of right mindfulness and African wisdom baseline for the intervention group, combination baseline for the control group, and then the end-line score. So those are the different combinations we're going to do. So in the first analysis, we want to do the paired t-test. Come to analyze, come to compare means, come to paired t-test. So you want to compare the baseline for the intervention group and the end line for the intervention group for right mindfulness. Then you come to the control. You also want to compare the control for the right mindfulness and its end line for the right mindfulness. Or maybe I can do, let me do one pair at a time. So let me just compare the intervention group first of all. So this is what I have. This is what I have, the analysis I have in here. Okay. So when I compare with what we have in the write-up, the one that Starter gave us, we can see that it's saying baseline right mindfulness. We have mean of 1.982, mean of 1.982. The end line is 1.826, end line 1.826. And then this is the mean difference. The mean difference is below in here. Okay, that's the mean difference below here. The other thing, so our mean difference will be here. So this is the mean difference. We have 0.156, 0.156. This is negative. If you come to our equation has baseline minus end line, but it's supposed to be end line minus baseline. So let us reverse that. So depends on what you have put first. So you can reverse, because you have to do end line score minus the baseline score. So let's go back to compare mean. So let's go back. So I have to put the end line score first. Right mindfulness DV end line intervention versus right mindfulness DV in the baseline. Yeah. So that I can be able to have negative 0.156 as we have in here. These are the standard deviation 0.798 if you round it off. Standard error is indicated right in there. Then the correlation coefficient value is up here, 0.144. At this step, it was not really very necessary to add the correlation coefficient value, because we just need the t-value which is down below, which we are reporting down, that we could literally add. Then the significance of that correlation value is 0.425. But in terms of the pair t-test, which is down here, is where we have reported that details down here. So the t-value is also reported right there, the 1 point. So the t-value will be here. So t-value is negative 1.125. The confidence interval, it's here, right? And then the degree of freedom, the DF, the degree of DF is here. Then the significant, the p-value is 0.269, which is 0.269. So that is what we have. Okay. Then we go also to the next. In the control group, you also repeat the same thing for the right mindfulness. So when I come to analyze, I come to compare means, paired sample t-test. I can take back this pair. So I need control. So right mindfulness DV control end line versus right mindfulness DV control baseline. So those are the two pairs. Then I click OK. Then you'll be able to find out that in your control group, again, you have this particular value. The baseline score, the mean is 1.87. So baseline is here, 1.87. And you can see those values in there. The correlation coefficient value, and then the significant value, the p-value, 0.027. That is for the correlation value. If you come down here, you find the t-test statistics, things like the t-value, which is 4.909, things like the significance, which is 0.01, things like the confidence interval here. So you also find it and you record it accordingly, amongst others. So make sure it is end line minus baseline. That's when you'll be able to get the score. But even if the scores gets reversed, even if it's baseline minus end line, it's only the mean difference, this difference in the mean score, which will be negative. The sign will differ, but the p-value remains the same, the correlation coefficient remains the same. So even behind the scene, it's not always a very big crime to reverse that formula, since you're looking into the mean difference. As long as you know how everything is being done. So you do the same thing for African wisdom, and then the same thing for the intervention. So literally, this analysis could be done in a single take. So come to compare mean, paired sample t-test. Let's say there were no pairs here. So you just make sure all the pairs. So I would make the first pair, right mindfulness, end line versus baseline. Then in the control group, I have end line, first pair versus baseline. Then I come to African wisdom, which is these four. Now I need African wisdom end line intervention group versus its baseline. Then I need its control group African wisdom end line minus African wisdom baseline. Then I come to the last part, which is the combination. Take the end line intervention group versus baseline intervention group. Take the end line control group versus baseline control group. So those are the 6 combinations. So you can do that in a one take, and then you'll be able to have all your output in here for all the different pairs. So all this other section could literally be run in that single take. So from the all of this section for the paired sample t-test, you can literally run all the 3 intervention based on that. So the 3 intervention plus their 3 controls, those will give you the 6 different pairs which we have in the output. So literally, that is what you would be able to do, so that you have that given to you in a single output. And then you just interpret the results. The next section for the analysis is the predictive analysis. So this study also wanted to find out that could the variables, the demographics, have some association with somebody's healing status, somebody's trauma healing? Could it have been an issue? Could it affect it? Is it a big deal? Does your demographics affect that? So this is where we bring in the issue of logistic regression, because we have the dependent variable whether you have healed or you have not. So under the data for model, here we have the different variables in here. District of residence. We have different variables. We have somebody's residence, gender, age group, religion, all these variables. Then at the end of the day, we have the healing score in here. 0 means they have healed. 0 means they have not healed, and 1 means they have healed. So we want to look at the predictors of the healing status based on the people's social demographics data. So it would be good, since it is a binary outcome, healed or not healed, it was much better to run a logistic regression. Now there are 2 steps to run the logistic regression. We first have to run the bivariate analysis, the bivariate logistic regression, and then we can run the multivariate logistic regression. So those are the two we are going to analyze. But if you run the bivariate analysis, then there are some rules there are some conditions that must be met by the variable for you to consider it for the multivariate analysis. There are some rules that must be considered. But let's go through some of the basics. So first of all, in this analysis, the variables we are going to consider are just there are some variables we will not consider because they had so many categories. Like this question 2.8, what is your main source of income? These are so many categories which, if you try to run the logistic regression, the values cannot make sense. Sometimes you need to regroup so that you have fewer values. Also, this question Q211, what is your relationship with the person that has ever had trauma? This also had many subcategories and it wouldn't make sense. So some of those questions we are going to leave them behind. Also, entry level we're not going to consider because this was these are all baseline scores. Like before the study, that's when this data was collected, so it's not important to run. Intervention group we could add, we just maybe to know whether if you are receiving African wisdom only versus receiving combination versus receiving right mindfulness, could it also be a predictor to somebody's healing? Okay. Now we can consider that, but this second last, the healing score, we are not going to consider because it was used to calculate the dependent variable here, which is whether have you healed or you have not healed. Now, to perform logistic regression, you need to ensure that your data is encoded. Your data is numerical in nature. If it is string, then it can't run. Now, that is where the concept of coding comes in. Oh, if it's male, let it be 1. If it's female, let it be 2. If it's age group, let it 1 to 1, 2. But encoding manually like that, personally, I don't do that. It takes a lot of time and like it makes it harder for you to interpret. So there is a faster way to code your data. We call it data encoding. There is automated encoding that you can use to encode this data automatically in SPSS. In Starter, if I show you a sample command in Starter, how it would look like. So this is how the Starter command would look like. You would do encoding one variable per time. So you convert this variable, this week of residence, then you generate a new variable which will be numerical in nature, sort of. So you do encoding for all the variables. Then you drop the variables that are strings in nature. Now then this is your dependent variable. Then you can begin performing the logistic regression, binary logistic regression, where you have the dependent variable versus the independent variable. Then you get the odds ratio by adding I dot. That gives you the odds ratio. Then later, after running the bivariate logistic regression, you can then perform the multivariate logistic regression, where you put now multiple independent variables that have met some conditions all at the same time. Then you run the analysis to see whether the model will perform better, whether it will predict healing much better or not. So it's also the similar thing we would go through under SPSS. Only that in SPSS, it's a different step. So for SPSS, what we shall do, we are going to, let's import our data first. Let us import our data first. Come to File, come to Open, come to Data. So we're going to import the Excel data from this data set of ours, the Excel. We're going to import the worksheet called Model, because that is where the data for the model is. So this is our model data. Okay. Let me close the previous data because we don't need. Now this is our model data. Now you can see that these are different variables that are available that we may need. We may not need all of them, of course, as we have seen. We need some. But what I need to pay attention is the data type. This data type is string in nature. But we need to like convert these strings into another format so that it can be able to run a logistic regression. So the simplest thing to do is to come to transform if you want to automatically encode those data so that it can be numerical. Come to transform, come to automatic record, click on that. These are the different variables now you want to convert from strings. It detects that, oh, some of these, or these are variable. What do you want to convert it? Because you're converting it into numericals. Okay, give it condition. So you need to take one variable per time. So here I say this week of residence, I want to transform that because we need that one in our analysis. Then you need to specify the new name of the variable, the new name, because after generating the numerical data, you want to it must generate a new name. So I want to generate a new name. So you say add new name. So here it will say after recording this, after doing the recording and the rest, it's going to convert it and it will create a new variable called residence. Residence is going to be the new name. So that is very okay. So here also male, female. So also take that. So that will be gender. So you give it name. The next one, this is marital status. So you can't put exactly the same name, otherwise it will bring an error. You can't put exactly the same previous name. Next, so you remember every variable you take the other side, it keeps on disappearing from the left-hand side so that you don't get confused. So next is age category. So I can call that an age group. Now, if you want to put a space, you need to put an underscore. If you say you're going to put a space, then it doesn't accept. Space is regarded as a character. It is illegal. So when you want to put a space in between that, put an underscore. If you put again this in the middle, it doesn't allow. That's also illegal. Because this can be interpreted as minor, so it doesn't take that. So you need to put underscore like down there. So next is religion. That one can remain as religion. So what we're doing encoding, where we change strings into a numerical data, but you cannot it cannot change it from the original variable you have. You need to generate a new variable. So that's why we are putting these new names. So these are like the new names for the new variables we shall be generating. So that is why we are trying to generate all these. So you need to do this one by one, and then you generate. Household income I don't want. Did you know anybody in the past 12 months who had trauma? Yes. I need question. Let me confirm the other questions I need. I just want us to use the same variables we used in starter. So we had after are you the head of household? Yes. Education level? Yes. Then we have this part, the financial status, such like financial status in the past 12 months. So we need that. So we are going to, so this is this variable. How did you, yeah, this is in the past 12 months, so that is financial. So I can call it financial status. Financial status. Financial status. Add that. Next is the household income. What's the main household income? That we don't need because there are so many categories. Do you know anybody with the trauma? Okay. So we can add that. So that is variable question 210. So let's confirm that whether that is what we need. Question 210. 210. Yes. So we need that. We need that. So know someone. Let me just put here that know someone. Next here, question 211. What is your relationship with that person? We don't need that because it's what I said. It had so many categories. It wouldn't make sense to include it. Maybe if this could be recategorized into like fewer categories. Then question 212. Do we really need that? 212. Yeah, have you been performing any activity? Have you been trying to make a living? Have you been like active working? Are you like being engaged, like something like that? So that's why we have that. Where is it? Yeah, have you been like any activity? Like, as that person being active in some way? So we need that. Which other variable do we need? Next is entry level and the intervention type. Entry level, we literally wouldn't really need that because entry level is baseline, endline, everything is baseline, so we don't really need that. I leave entry level. Intervention we may need because we want to maybe see the type of intervention. Could it be a predictor? Let me say. Oh, okay, so this is it's exactly the same name. So let me add your type. All right. It was warning. So those are the ones. Then you need to use the same recording scheme for all variables. And then treat blank string values as user missing. You have to click that, choose yes, treat the blank string values as missing. So in case there is a blank space within that data, let it be missing. Yes, treat it as missing values. I tap on it. That is it. So that is everything you have in there. Okay, you can press OK, and then it will perform for you all the different encodings. Now you can see the difference in here that after you performing that specific encoding, it has assigned some values to your data. It has assigned some different values to your data, but maybe you don't like, because this is assigned 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe you don't want that. Maybe you want, like, let's say males to be 1, female to be 2, and then if it comes to religion, Anglican, let's say, to be 1, Catholics 2, Muslims 3. Maybe you wanted to again go back 1 to 3, 1 to 3, 1 to 3, 1 to 3. Therefore, we need to click off the previous option that we had chosen. So if I go back to transform, automatically record. If you want to use that format 1 to 3, 1 to 3, then you have to click off this one here. If you click off this, you can be able to what? To be able to generate. But because we have originally generated the variables, so now it says that okay, it has already generated the previous variables. You can't change anything from there. So meaning either again you discard off whatever you have done, or you sort of again modify the name, modify that name of like what we already have. So I think maybe I could just modify that name. So again, I have to go one by one here. Residence, I say now residence 1. So now because that is in case you want to generate your codes, which is like 1 2 3 1 2 3 1 2 3. But in this previous one, we had generated 1 2 3 4 5 6. It didn't, like, it kept on moving forward, like it didn't repeat. So it depends on the use case scenario. But in this case, most people do really prefer that they have 1 2 3 1 2 3 or 1 2 1 2, depending on how many different categories it has. So I've added 1 1 1 1 1 at the end of all my variable name. So I've clicked this off, then I press OK. So it should be able now to generate the variables that has residence 1 2 3 4, gender 1 2. Depending on how many categories are there, it will always go back to 1 2 1 2 1 2 3 1 2 3, depending on how many groups are there. All right. Now that you've seen that, now we have now to perform our. Now let's go back to the data and we see. So we can see that now in the data has been generated more and more and more and more. Now, if you look at the new variables I generated in here, from where we began from residence, see now it's numeric in nature. If I begin from where I had my residence 1, gender 1, it's also numeric in nature, etc. And what's interesting is that if you look at under values, you will be able to see some interesting things. So under values in here, when you click here, you see it has all those subcategories it gave. So when I go down to my variables 1 2 3 4, if you see it, lowest highest is that. If I come into education level, for example, then you click here, you see. Now this is the coding that you see most people putting on YouTube, that 1 is equal to, then they open quotes, then they begin label defining and the rest. It's a very tedious process for you to go each and every time. 1 is equal to female, 2 is equal to male, yet you can automatically encode all these values so that you straight away have your values like automatically like coded. So that is how easy that I always go about that. So having transformed the data, let's now perform our logistic regression analysis. So to perform that logistic regression analysis, go to Analyse, okay? Go to Analyse, go to Regression, come to Binary Logistic. Binary Logistic Regression, click on that. Now, once we are here, it will ask you to specify what is your dependent variable, the dependent variable. So, your dependent variable is healing. Where is healing? Healing status. That is, if you go back to Excel, we need this last column, which is 0101. That is the healing status. If it's not 0101, it won't run. It won't run. It must be 01, not 12, 01. So logistic regression models understands that 0 is the outcome not of interest, then 1 is the outcome of interest. In this case, we want to analyze and see the predictors of healing. Healing in this data set is being denoted by 1. So if you don't put your data here to be 1, it won't be able to recognize that outcome. It will bring an error. So that's our dependent variable. Now, the independent variables will be put under these areas of covariance. That's where we want to put it. So in the first phase, we want to do districts of residence, for example, districts of residence. So I go under residence. Remember the last one we generated, residence 1, that's the one I want. I take it that other side. Next, here there are other options. You have to maybe specify some data, try to give information about it, and which other statistics do you want to report. On top here, you have what's called the categorical. It asks you, is this data you have chosen, is it categorical in nature? Is it categorical in nature? So you can choose that, yes, it is categorical in nature. So And we know residence category because it's divided into different. Remember, you can also run the logistic regression using continuous data, but this is categorized. So I say yes, I take it the other side. Now, what is the reference category? Which reference category would you want to make the reference? Yeah, the reference group. So, like in this case, if you go in this write-up, you can see that this is the reference group 1.00, and these other ones are being compared with that reference group. So, in Stata, the reference group is chosen based on the ascending order, the numerical, the alphabetical order. It's ascending order. So you always consider the first one to appear under the ascending order to be the one to be considered as the reference group. So in this case, if you want that to be the reference group, then we choose the option of the first. We want the first to be the reference group, like the first in terms of the alphabetical arrangement. Then you click change. So it will say, okay, reference group indicator first. So it will be the first. Then you press continue. Let's save under save option. What other things do you want to save from there? Probabilities, predicted values, and the rest. No, we don't really, nothing much important. We need that, but we may need logit. We need logit. That is the odds ratio. We need that logit. That odds ratio is going to be very, very important. Do you need to include the covariance matrix? We really don't need that. It's not a very big deal. If you're doing logistic regression, it's always not an important statistics to report, so I can put that one off. These predicted values would create for you new variables, because remember, it's developing a model, so it will generate for you some new variables, and you don't want to be generating new variables anywhere. I click continue. Under option, what other thing do you want to report? Classification plots, case-wise, iteration history, CI, the confidence interval for the exponential B. I click that yes. The exponential B is more like the odds ratio. So the odds ratio is, at first you get the regression values. That's what you get, the regression coefficients. But for logistic regression, you want to report odds ratio. So odds ratio is always the exponential of that regression value. So you always get the exponential. So you need to also report the confidence interval for those odds ratio. So that's what you also click. Include the constant in the model. It's always not a very big deal. You can leave it, but you don't always report. But you can always leave that. You can always include it in the model. It's fine. Bootstrap, there's really nothing you really need to add there, so you need to leave it open-ended. Then you can press OK. So after that, it has performed for you the analysis. So up here it begins case processing. It shows you the variables, the original value, then the internal value. Nothing important from there. It shows you the frequency distribution in here. Okay, and how it was encoded, 1, 2, 3, how it was encoded within when we did the automatic encoding. Next in here, it's here showing you the two-way distribution of the dependent variable. Okay, versus the two-way distribution is sent to two-way, more like how this one also did the two-way for the different independent variables, also performs the two-way for the independent variable, and then naturally the distribution is that's not a very important stat to report. Variables in the equation, this is the model itself, how it is generally performing, the scores, the constant value. This is the constant value, something like that. It's not a very big issue. Here is variables not in the equation. So these are the different residence 1, residence 2, residence 3. These are different scores, degree of freedom, and then the significance is also indicated in here. As you keep going down, there are so many stats it keeps on reporting as you keep going down. The most important statistics I want you to focus on is the last one, the variables in the equation. The variables in the equation is what I want you to focus on. That's what I want you to focus on. That's the variable in the equation. Okay, so what do we have in here? So we have the different variables here, and then we have the significant value here. We have the exponential, that is the odds ratio here. And then the confidence interval, we also have it here. Those are the main stats we really need. And if you compare with the output we have, the finding we have in here. Okay, let's compare the interpretation. So we have on the right hand side under the exponential, this is the odds ratio we need, first of all. So when you're presenting, the first section is a two-way distribution, the frequency distribution between the independent versus the dependent. So it's not always so your data, you always perform it the two-way table earlier. It's not really, this literally really not part of a logistic regression, but we just add it to add some more description to the relationship we are trying to show. But from here is what we begin reporting. This is now the part for the logistic regression in here, the odds ratio. So here we can see that the different odds ratio have been indicated, and because we performed only one variable per time, that is what we call the odds ratio you get is called the crude odds ratio. The crude odds ratio is what you get at that stage. So we can see the crude odds ratio. Sometimes the odds ratio are like 0.000, doesn't really, it's just constant. So it always happens in case the independent variables are not distributed in the dependent variable. Like, they cannot really predict anything. It gives 0.00, or it gives a very weird score like this, a 999999411. It's a very weird score. It doesn't make sense. So in Stata, it's recorded as 1.00, or it's even written as omitted. Like, omit, can't perform this analysis. Omitted, we can't have anything. But when in a report, we just put 1.00, 1.00, 1.00. But the one which is able to run, like this last one, 3.077, those are people who are from this district. This, we said, they were 3.077 times more likely to heal compared to their counterparts who are from this reference group, that is this compiler. And the reference group in here, it tells you that it's residence 1. So residence 1 is the reference group. So you can always ask yourself, what's residence 1? Residence 1, and whether it's interpreted somewhere earlier. All right, residence 1, by default, residence 1 is compiler. So you just know that, oh, residence 1 is this one. Let's try the household size. Household size. So to perform the logistic regression using the household size, I come to Analyze, come to Regression, bivariate logistic, take back what was there. Yeah, healing status remains here as our dependent variable. So I need household size, and it's here. This is what we need. We want to calculate that. I take it here. Then I come to categorical, say, oh, this is categorical in nature. Make the indicator, let the first be that, the indicator. Then I click on continue. Then we click on OK. When I come down and look at my values in here, I can see that the odds ratio are also agreeing. Okay, 0.850 is the odds ratio for this last category. Then this is 0.000. As I said, 0.000 just recorded as 1.00. That one, in most cases, you have the distribution 0 somewhere, like the distribution of the participants between the dependent variable is not, there is somewhere which is 0. If this was like 1, then we would be able to see some value. But since it is 0, it cannot. In Stata, this will be written as omitted. But in SPSS, it tries to calculate something. But now you see, even under confidence interval, it doesn't give you any value at all. It doesn't give you any value from there. Let us try for the financial status. Financial status, come to Analyze, click on Regression, do bivariate logistic regression, look for financial status, which is here, take it here, categorical, yes, it's categorical in nature, change this to be the first, click on change, OK, and press OK. Then it will analyze for you that. We can see the odds ratio is 1.149 here, 1.149, that is for this second category compared to the reference group. So people with the very lowest financial status are 1.14 times more likely to get healed compared to the people who have an average financial status. So that is the finding in there. But for bivariate, it's not always a very accurate prediction. It's always, that's why we always report crude odds ratio. So we want to do multivariate. So multivariate, those are the variables that had p-values less than 0.25. Those variables, if you have p-values less than 0.25 at bivariate logistic regression, you can qualify to be considered for multivariate logistic regression. Now, the odds ratio we always get from there is called the adjusted odds ratio, and it is the one that we report as AOR. If you read articles, you'll always find AOR for adjusted odds ratio. So in this particular work, we want to do, we found out that district of residence, gender, religion, is that person active, like the person who is traumatized, are they involved in any activity, then a type of the intervention. They really qualified for multivariate logistic regression. So let's run it in SPSS and then you compare the values to see whether it would match. So now here I need multiple variables: district of residence, gender, religion. So let's do that. So for the analysis, so I come under Analyse, Regression, Logistic, binary logistic. Let me just remove what was there. So I want where do we have residence first, we have religion. Remind me, what do we have residence, gender, religion, residence, gender, religion, residence. I have the residence 1, gender, religion. We have activity, then intervention. Activity is here, then intervention type is here. Those are the things we have. Go to categorical. All of these, so select all of them, transfer this other side. All of these are all categorical in nature, and I want the reference group to be chosen based on ascending order. So click on reference category first, then you click on change. It will change all of these. Click on continue, click on OK. It will perform that multivariate logistic regression, and then you will be able to find your output in here. My most important is down here, the different odds ratio. This is the exponential B at the odds ratio I need. This confidence interval also I need, and then this p-value also I need. So these are the last 3 things that I do report in the write-up. So here we can try to see some comparison to see whether does our output agree with the what we found when we use Stata. And the district of residence, we can see that Wakiso had 1.7. We are looking into this column for the adjusted odds ratio. That is the column we are looking at, adjusted odds ratio. So Wakiso here, this is the last residence here, this last one. Odds ratio is the adjusted odds ratio 1.750, which is 1.750. That is it. That's what we have. So these other ones, this is too high and this is too low. Some of these distributions, as long as you don't see confidence interval, it means that those are like faulty values you can't report. So it's just easier to report them as 1.00, 1.00. That is much more, it makes much more sense. If we try gender in here, so gender, we can look at it is this 4th value, gender. So gender also is 2.289. You can see 2.289 is here for the male, meaning the reference is a female. So that is our adjusted odds ratio. So as you get along, that is what you find at religion, etc, etc, etc. That is what you find throughout all this. Even the last one in here, the intervention group. So the last one, the last category, intervention, 1.033. This is 1.032. Well, it's a rounding off error. But by that 1.03, you can see that it agrees perfectly very well. And so that's how you'd perform the multivariate logistic regression compared with the bivariate logistic regression to be able to accomplish this particular task. Then in front, after reporting that, you also report the confidence interval, 95% confidence interval. So we only report for the multivariate now because that is the most important thing. So here we're only reporting for the multivariate. So that's the confidence interval we report here. A p-value, this column sig, those are the p-values. Those are the ones we report on the right-hand side here, the last one. And you're basically done with all the analysis. So this is just a write-up for that part, and that is it. So the interpretation are things like okay, people who had right mindfulness-based intervention were 1.032 times more likely to heal compared to their counterparts who had African wisdom-based intervention. Religion, here. People who are Catholic were 1.092 times more likely to heal compared to their counterparts who are Anglican. Right. Islam. People are 0.289 times. Okay. People who are Muslims were 0.289 times less likely to heal compared to their counterparts who are Anglicans. That's how you'd be interpreting your values. And that brings us to the end of this analysis. It is a very extensive data, a lot and a lot and a lot. And the video is really so long. Editing has been a little bit tight, but I'm glad if you have understood, try to follow along, that will be okay. If you have any question, you can reach out, but that is how you analyze using SPSS.